Geospatial. Geo means earth and spatial mean relating to occupying or having the character of space or relating to facility in perceiving relation as of objects in the space. Like you are collecting the data related to the things which are present in the space on the earth, that is called the geospatial. What is about geospatial sciences? In this lecture, I will discuss the difference between the geospatial and the geospatial sciences. That what is the difference between these two? Geospatial is a data, right? That we are collecting from the earth, from the space, that all of the element, the climatic factors, the construction infrastructure, all of the things which are present on the land, on the space, that is called the spatial, that is called the, and the data is called the geospatial data. And the difference between the geospatial and the geosciences is geoscience are the study of where object or phenomena are and how they relate to each other. Means the relationships of the data and their environment and the parameters of the environment and the things like the human relationship with the infrastructure, with the roads, with the climates, with the flora and the fauna of the area, generally relating to the earth's surface or near the surface. Earth surface means the data of the geology, the data of the medical sciences, the data of the infrastructure, the data of the environment, and relate near to the earth's surface, that is the data which is related to the climate, related to the layers of the ozone, related to the rain, related to the seasons. So that is the data which is present above the troposphere, that is called the geospatial sciences. Here, one question is very important in the GIS and remote sensing, that where. The question where, that is very important, that all of us know about the where. Since almost everything happens somewhere, knowing where that something happened is critical, right? Okay, the where example, from the GIS and the remote sensing data, we have collected the information and we know about the, for example, somewhere the floods occur. So we know about that, where the floods occur, where which is the position of the population, what is the position of the population, what is the condition of the area. So here the where is really important in GIS. Knowing where is important says almost everything happens somewhere. Knowing where that something happens is critical. For example, hurricanes occur. So for that, why we know where is the hurricanes occur, for the purpose, for example, why, what is the path of the hurricanes, what are the evacuations of the hurricanes, what are the damages of that hurricanes, and what are the utilities which are used, which are destroyed by that hurricanes. So that's why the where word is very important in GIS and remote sensing, that all of you know about the where. GIS. Now come to the main topic, that is about the GIS. What is GIS? The simple definition of the GIS, it is a set of tools which collecting the data, storing data, manipulating that data, retrieving that data, transforming and display of the spatial data from the real world. Like if we, for example, we are living in the real world, here some hurricanes, some tornadoes, some cyclones, floods or diseases, any kind of pandemic occur. So from that point of the real land we are collecting data, then we, the collected data are stored in the hardware. Then in the hardware we are going to manipulate the data, retrieve the data, and that data is transferred to the display as a spatial data in the form of maps. GIS is a combination of the three words, that is geographic, information, and system. What is geographic? Implies that location of the data items are known or can be calculated in terms of the geographic coordinates, that is called the latitudes and the longitudes of the area. So that is called the position of the area of the object, that is called the geography, right? Information implies that the data in a GIS are organized to yield useful knowledge, often as colored maps and images, but also as a statistical graphics tables and various on screen responses to interactive queries. That is the data we are collecting, and after the collection, we store and manipulate, and that display in the form of a spatial data, in the form of a map, images, and the graphics and the tables. That is called the information. The system implies that a GIS is made up of from several interrelated and linked components with the different functions. The GIS have functional capabilities for data capture, input, manipulations, transformations, visualizations, combinations, queries, analysis, modeling, and output. In a system we have to study about different things. That in the system we are using the Microsoft softwares, different types of computers and these things, and through that system we are capable to input the data, and that after the input, manipulations, and transformation, the data will occur in the form of visualized data, in the form of map or any kind of the model. Further we will study about the models and the maps and types of the maps and models. Another one definition of the GIS is, what is GIS? GIS is a geographic information system. Link the database in the map, manages information about the places, help answer questions such as, the first one question that I have to discuss about, that where is it? Where is very important, right? Where is it means where is your geographic location? What else is nearby? What are the area? What is the geography? What is the location that is nearby that position? Where is the highest concentration of X? X means something, X, Y, and Z, right? Where can I find the things with the characteristic, like what is the highest concentration of, for example, temperature in that area? uh, where can I find the things with the characteristic Y? Means ke, the things which is near to that X position, what are the highest position and what we have to find about that Y position. Where is the closest Z to my location? Another one thing that I have selected for my analysis, for data collections, for data interpolations, what are the things which is near to the Z? Like in IDW model of interpolation, we have to study about the place, about the sample place, and that give us the data about the near places, that is Y and Z and so on. What is GIS in the form of technology? A technology, hardware and software tools, and information handling strategy. The objective to improve overall decision making. GIS is also a hardware and it also a software tool, right? And information handling strategy. Through this, we are going to gather the information, and properly we have to handle these information, like in the form of data collection, data interpretations, and data display. And the very important point about the GIS is, it is to improve the overall decision making. In a simple map, it show all your decision about the geography of the area, about the data of the area, about the maximum and minimum contaminations, and the maximum and minimum concentrations and values of all your data. It show in a simple map. GIS, a formal definition: a system for capturing, storing, checking, integrating, manipulating, analyzing, and displaying data which are spatially referenced to the Earth, the data which is spatially referenced to the Earth. This is normally considered to involve a spatially referenced computer database and appropriate application software. Right? You can understand. I think from the it is a very easy definitions that this is a system of capturing a data, storing data, checking the data, that you have to cross check the data, that is it right, integrating the data, then after integration you have to manipulate in the data, analyzing and display in the form of a spatial reference data. Why is GIS unique? GIS handle the spatial information. The word spatial mean that is related to your land that have a coordinate systems, that is x axis and y axis, latitude and longitude of the geography, that the data you collect with the coordinates with the longitude and latitude, that is called the spatial information. Reference by the location in the space. GIS make connections between activities based on spatial proximity. Now come to the concept of the GIS, from where the GIS concept is started. From the pandemic of the London 1854. In 1854, the cholera, that is epidemic disease which causes there in the shape of a big pandemic where a lot of people are died and a lot of people are suffer from this pandemic. The first one person that he was Dr. John Snow. He used mapping to illustrate how causes of the cholera were centered around a water pump. Many people thought that the disease was propagating through the air. However, this map helped show that the cholera was being spread through the water. Dr. John, he was not a geographer, he was not a geologist, he was not a GIS and remote sensing specialist. At that time, there was no concept about the GIS and remote sensing. He was a simple medical doctor. He find a map and he collected the data about the cholera patient. From that data, he discovered that those people are ill and those people are died because of the chlora which are near to the water resources, and the water resources which are responsible for causing the waterborne diseases. At that time many people thinks that the pandemic of 1854 in London was because of the air pollution, but from the discovery and from the data collection of the Dr. John Snow, he said that the chloride is because of the water pollution. So, for that purpose, he made a map and he pointed that the population which they drinking the water from these wells and tube wells and the water sources and the water pumps, they are mostly affected by the chloride. So he say that the chloride is basically a waterborne diseases, and the people who are using the polluted drinking the polluted water for drinking purposes, they are affected by the chloride. And he show all of this data through a map. So first of all he show this is the first map which show that the diseases is because of the water pollution, and from this the GIS concept was started. Another one person that he is called the father of the GIS, he is a Roger Tomlinson. In 1963, the geographer Roger Tomlin's sons began a national land use management program for the Canadian government, interviewing natural resources. Tomlinson's first coins the term Geographic Information System, that is called the CGIS. CGIS means the Canadian Geographic Information System, and become known as the father of GIS. First of all, he make a software for the Canada through which he used the GIS system, and that GIS system was called the CGIS. GIS historical background, how GIS at that time was using, what was the software, what was the hardware, and what was the attribute that they were using in the GIS. This technology has developed from digital cartography and CAD. CAD was the software, database management system. The data was collected, that it was like a Excel sheet. The data was interpreted in the sheets and then managed all this data. Now come to the process of GIS, how the GIS is working, how the GIS through which we are collecting the data. First of all, we are capturing the data, then the data is registered, then interpreted the data, convert the data to a digital forms, and store that data in a computer, process the data and display the data. That all of this process we have discussed already in the definition of the GIS and remote GIS, right? This is the GIS system through which we can what we are doing in the GIS software. There are two types of the data. Further, we are going to discuss in detail about the data, that is spatial data and attribute data, right? GIS data layers stakings. What are the layer staking? Through the GIS, we can, in a single map, we can show different layer of the temperature, different layer of the atmosphere, precipitation, rainfall, mountains, vegetation, navigations. So, in a single map, we can show multiple layers of the geography of the area. GIS areas, through GIS, which one areas we can, that is applicable in which areas. So it is applicable in geosciences, civil engineering, transportations, natural resources, geology, and geophysics, environment, planning, administration, management, businesses, remote sensing, image processing, urban and rural development, flood, disaster, oil exploration, mines, survey, watershed management, tourism, and communication. I think GIS is a field it is applicable everywhere, and I think there is a need of GIS, that everyone know to learn to use the GIS, because it is a broad subject and it is used everywhere. The software which is used in GIS, there are different software which is used in GIS, that is Arc Info, ArcGIS, Map Info, Graphs, GeoMedia, GeoConcept, WakeGIS, MicroStations, AutoCADs, ADAS, Imaging, ER Mappers, Ilvis, Envy, PCI, Geomata, Arc View Image Analysis, TNTM IPS maps, and eco organizations. There are different software, and inshallah we will give you the information how to install. We will give you the tutorials how to install the software for your study. Major services in GIS. What is the services which GIS provided? GIS application software development, remote sensing application projects, thematic mapping for something theme, you have to digitize the map. Digital image processing services, engineering application software solution, data conversations, complete GIS implementations and consultation. These are the services which GIS and remote sensing provide to the user. Now come to the component of the GIS. They are the most important and the basic component which is used to run the GIS, which is used to run the software. So the first one thing that is very important, that is called the hardware. Hardware is a computer system. It includes the CPU, video, keyboard, mouse, plotter, printer, CD, DVD, drive, etc. to store the process and present the spatial data. Another thing, in the another one definition I told you that GIS is a software and GIS is also a hardware. So in a software, it includes the software like ArcGIS, Mapinfo, Geometrica, and other software that we are using for different purposes. No, this is the process of the GIS, how to collect the data, interpret the data, manipulate the data, and at the end you got the output of the data. Third one point is called, that is very important, that is called the data, collection of the data. Geographical data in a form of hard copy, map, digital map, aerial photos, satellite images, statistical table, other document used for the GIS operation. That you are collecting the data from the terrain, from the area, from the space. That is called the data, and the data may be in the form of images, maybe in the form of table, maybe in the form of statistical table, maybe in the form of aerial photography. So that is, you collect that data and then interpret the data into the computer. Procedure and analysis is the fourth point, that is called the procedure and analysis of the data. To complete the task, procedures are performed using the hardware and the software. Through hardware, you are storing the data and analyzing through the software. Expert and skilled persons. The fifth point, if you have all of the 4 points, that you have the hardware, you have the software, you have collected data, you have a lot of information about the geography, you have a procedure and analysis, but you don't have a skilled person that who run the GIS software. So all of the data is, I think, useless. Experts with the knowledge area required to apply the GIS properly. Different types of the user are using the GIS at different level. What are the main function of the GIS? We have to study about the definition of the geography, definition of the GIS, the function of the GIS, the application of the GIS. Now come to the function of the GIS. What are the function of the GIS that we are going to give importance, and worldwide GIS is taking importance. So the main function of the GIS is capture the data, digitizing, scanning, importing manual data entry. Data storage and management, database design, data integrations, data manipulations, editing, cleaning and editing of the data, resolving boundaries, layering, and georeferencing. The data display of the data in the form of spatial and attribute data. Now come to the data manipulation and analysis. Spatial analysis, there are different types of analysis. That is called the spatial analysis. In spatial analysis, we have to focus on the simple searches, network analysis, buffering, corridor analysis, proximity analysis, Boolean analysis, that is union, intersection, etc. etc. Further, I will give you the brief introduction, the brief study about all of these analysis, right? But this is your introductory class, so I will give you just a clue that in your mind all of these words are clear. Presentation and visualization, how we can present and visualize the data after collection, manipulation, and interpretation using the software. So the data are presented or visualized in the form of map, charts, table, 3D views, generation, and animations, etc. This is, I think, the last point of all the software system, the GIS system, through which the data are visualized. Now come to the application of the GIS, where we are using GIS. It is mostly used in agriculture, archaeology, architecture, landscape, business, computer science, environmental science, engineering, journalism, military science, natural resource management, geography, geology, meteorology, oceanography, law enforcement, public health, history, sociology, urban regional planning. I think the geography is one of the science with the study which is used every field. Like the military sciences in our country, Pakistan and other countries, they mostly uses the GIS remote sensing for the to target another one country through remote sensing. In agriculture, how the GIS is used farm management, pest diseases tracking, crop monitoring, yield reductions, and soil analysis. Which kind of soil is fertile soil is good for the agriculture purposes or not. For this purpose, we are using the agriculture GIS. Natural resource management, forestry, ecology, mining, petroleum, and the water resources. We have to show all of these that forest and natural resources. So through the GIS and the remote sensing, we have to capture the geography of the forest and show the data on the map that much of the natural resources. That will make it easy the study for the other scientists to learn about the different resources and natural resources. Planning economic development, land use planning, emergency preparedness, population forecast, market analysis, property tax assessment, and transportation. That is, GIS we are using the planning and economic development for all of these purposes. GIS is a framework for understanding and managing our Earth. GIS is basically a very easy and short learning tool that in a very short time we have to learn from a map, from a table, from a chart. They show what are the information which are present in the world, like for different tracking, like tracking in the car, you are using the GPS. Through the GPS is one of the tool of the GIS. So with this, you have to identify that where that location, that geographic location, where it is, and which is the destination of that location from you. Through map, you can study about the different location, about the different mineral studies, different natural resources, different population, roads, and infrastructure, which is present in the world. You can learn easily from the map. So GIS is a tool which makes your study easy. Geography matters. Today's challenge requires geographic approaches, climate change, urban growth, sustainable agriculture, water quality and availability, international and national security, energy, epidemiology, diseases, tracking, natural hazards, and seismicity, and weather events. All of these factors, all of these geography, your land related matters, we can study through the geographic information system, and we can show all of these matters, all of these events on a map. GIS is an infrastructure. Because GIS is used in many departments, coordinations is needed, software licensing structures and data. The GIS is working in different departments. So the software license, instructions, and the data, that is very important that every one person know about that. Data is the greatest expense. Previously, data scattered in multiple departments, not coordinated. Like I will give you example of the mineral maps of the or the resource map of the country. In a natural resource map of the country, there is a data of the forest, there is a data of the mines, there is a data of the different sources of the radioactive elements, which is the source of energy. There is a data of water reservoir, there is a data of the flora and fauna of the country. All of this multiple department data that was scattered and present in a multiple department, now through the GIS and remote sensing, it is collected only in one map, on one table, on one graph, so that visual representation of the data of multiple data in a single platform you can see. Libraries, data centers की GIS data has unique characteristic. The GIS networking, you can collect the data through mobile GIS, virtual globes, services GIS, desktop GIS. Desktop GIS, that is called the Arc Info, Arc Editor, Arc View, Arc Reader. The mobile is PC, PDA, and phones. The virtual globes, that is ArcGIS Explorer, the Google Earth, the Virtual Earth, and servers GIS, that is the ArcGIS server, and the portal locate. Geodatabase, that is in the form of files and DBMS and the XML. Civil engineering application. In the civil engineering, where we are using the GIS in the transportation to map the transportation system, the roads, and all of these things, the watershed analysis, and the remote sensing. Location allocations, to find out the location of the some geographical position, we are using the GIS and remote sensing tools. Finding a subset of locations from a set of the potentials or candidate locations that best serve some existing demands, so as minimizing some cost. Through this way, we are going to minimize the cost of the area, that we are not going to the actual position or actual point where the natural resources are existing. We are just collecting all of this data from the map, so it will make the collection of the data very easy, and that is cost effective too. Locate site to best serve allocate the demands. Application area are warehouses location, fast food locations, fire stations, and a school, that we people are using to search about the hotels, about the houses, about the fire station, about the school. So we just click on the Google map and search the exact location, to save the time, to save the money, and to protect our environment from the emission of the air pollution, emission of the pollution from your vehicles. Location allocation inputs, customers or demands location, potential sites location, and or existing facility, street network, or residence distance, the problems to solve. This is a very easy tool that even a layman can use the Google map, and he search the exact location where he want to go. Vehicle routing, through the demand customers, available sites, chosen sites, and the optimal paths. Vehicle routing means that is the road map, which is shown on the Google map, and it will make your way, your travel to the your destination easy. Synergy between the spatial data and the analysis. Imagine you are a national retailers. You need warehouses to supply your outlet. You don't wish the warehouses to be more than 1,000 kilometers from any outlet. Through the map, there is a position which is show, the coordinates are show, the distance are showing the meters. So through the maps you can calculate your destinations and all of these things. Other transportation applications, planning and locating new roadways, corridors. Transportation where you have to show the where there is a need of the road, where there is a need road that make the accessibility of everyone from every village, from every city, from every geographic position accessible to the cities, to the peoples, that make their life easy. Transportation emergency operations. Transportations makes our critical disaster responses plan can be developed outside computer models used for advanced warnings, land use maps, enhance the emergency operations. This is one of the best work of the GIS in remote sensing software and the analyst and the expert, that they show the critical conditions and the disasters on the map. And through this, they show the people that what are the effect of that disaster, what are the effect of that situations or the critical situations on the populations, on the communities and their economy and their property. So it will make that the preparedness for another one disaster, that people are prepared for the coming disaster or for the criticalness of the disaster. Relate the physical characteristic to the water quality and the quantity. This is about the watershed characterizations. In a watershed, how GIS is used. You know what is watershed? The in the mountain areas, this is one of the technology which is used to collect the rainwater and the extra water to store, and that water is used for the irrigation purposes and for making the energy sources in like in the form of small dams on these. That process is called the watershed. Relate the physical characteristic to water quality and quantity, data, land use and the land cover, geology, soil, hydrography. Hydrography means the water related studies, and the topography related to the hydrological properties. In this watershed characterization using the GIS and application, we are using the land cover, that how much land is covered by the water area, by the watershed, what are the uses of the watershed in that area, what is the geology of the area, what is the soil structure, what is the soil formation, the soil geology of that area, and the condition of the hydrography. So through this, different layers are formed, and in different layer in a single map we have to study all the hydrological related information about the geography. Watershed application estimate the magnitude of the high flow events, the probability of the low flow events. Determine the flood zones, identify the high potential erosions area, for example, the basins, HEC race, MIKE 11 models integrated with the GIS. This is one of the model which is used to show the soil erosion, the potential of the erosion, the high intensity of the flow of the water, and the floods. So through this watershed application, we studies about these sectors. This is one of the map which show the cross sections and the boundary condition of the area. In this, they have to show the data in the form of point and polygon. Further, we will discuss about the data type, that point, polygon, and area maps in detail. This also show the data in the form of map and in the form of graph. The graphical representation of the data are in this form. Stability analysis. Derive the physical characteristic, area parameters, flow path, length, maximum width, average, closing angles, watershed, topology, soil data. So we have to cover all of these parameter. Uh, we are not examining these, analyzing these parameter chemically, but we have to analyze these physically. So physical parameters, physical characteristics that we have to derive, these are the path, length, maximum, minimum width, average closing angle, the watershed topology, and soil data. Derive watershed characteristic, watershed boundaries, drainage system, network, slope, and aspect we have to show on the maps. This is the map which show the watershed in the country and the graphical representation of the watershed which is present in a high, maximum, and the minimum level. GIS data and a source. GIS is, I have told you that it is a software, it is a hardware, GIS is a data, and GIS is a source of information. Yes, G. Okay. Okay. Thank you so much. Okay, we have to start about the data structure. In a GIS, the data is in the form of the graphic or numeric and alphanumeric form. The graphic form is there are two types of the graphic form, that is spatials and non-spatial attribute, and the numeric form is in the form of already a non-spatial attribute. The spatial data is further divided into two types, that is called vector and raster. And the vector data is that type of the data which have a coordinate, that is latitudes and the longitudes, and the raster data that is always in the form of pixels and the form of image, which is present on the map. The the uh, image, the raster data is in the form of images, sorry, real aerial photograph and the remote sense scan images. Now come to the detailed study about the maps and the maps element that show you the different types of informations which is present on the map. Maps are the graphic representation of our perceptions of the world around us. They represent the cartographic interpretations and the simplification of the reality. Map provide two types of information, that is the locational informations and the spatial relationship. The maps contains the features such as point, line, area, and the surface, which give you the information. All of these features, all of these attributes give you different informations about the geography. For example, maps contain the point features, line features, and the area feature. The point features give you the information about the wells, control points, sample sites, and the fire stations, homes, schools, hotels. All of these informations are put by the point features. The line features give you information on the map about the roads, the railway roads, the traffic, the motors and the other street roads and the railway lines and the rivers and the counter lines. Area features give you information about the urban areas, water bodies, the soil, rocks, units, and the forest area. These are the things which different features of the maps. For example, in a point map, you have to show the trees, the phones towers, the phones towers, and the electricity towers, and all of these are shown through the points. The animals ranges lines, through the line map you have to show about the airways, about the railway roads, about the other routes, and the streams and the watersheds area, the chemical spills, right of the way, and the administrative area like the buildings, offices, and hospitals. All of these are shows in the area. Point feature: spatially distributed entities, activities, or the events points have a single geographic coordinate, such as tree, traffic accidents, and the lamp posts. On a map, you have to show the points in this form, like wells, sample sites, huts, and schools, and clinics, and homes, other wells, and the things are shown through the points. Line features: specially distributed entities. Specially distributed entities, activities, or the events lights, line arcs. Like arcs are a series of the geographic coordinates joined to form a line, such as the road, stream, and railway road. On a map, the line features are show these things: road, streams, and railways. These are the lines in the graphical representation. Lines are divided into simple line, complex line, curved lines, and network line. Uh, I'm going to give you a lecture about all of these points and these names, and these are the terminologies which are used in a GIS. So you people learn about these things. That this is really basic things, the basic language, the basic terminology which we are further use in GIS projects, in a GIS software, when you are doing your assignments, you are doing your projects. So these words, these terminologies, these processes will be used, right? So that's why I'm giving you the lecture about these things. Area features specially distributed entities, activities, or the events. Area polygons are a series of the geographic coordinates joined together to form a boundary, such as the lake and the soil types. For example, if you are doing analysis of something area, buildings, or any other lake or the soil type, so for that purpose, you are going to point the map through the area features, right? To a polygon map. That map is called the polygon map. In polygon map, you have to show the marshes, farms, urban area, lake, forest, and buildings, etc. If someone asks you about that, what the line map show, so you are capable that you give the answer that the line map show about the railway roads, about the tracks, about the street roads, about the streams, and all of these are shown through the line map. GIS data format. There are two formats used by the GIS system to store and retrieve the geographical data, that is in the form of raster data and vector data format. Like example, that is really clear for you people that in two picture, in a two model, I have to show about the raster models and the vector model. The raster model show the pixels of the image, right? The model is shown in the form of pixels, and the vector model, the model is shown in the form of attributes. Raster format. Data are divided into cell, pixels, or animal. Cells are organized in array. Each cell has a single value. Row and column number are used to identify the location of the cells within the array. Perhaps the most common example of the raster data is a digital image, like this one. This is the easy. This one is the raster model or digital image. Can we wait for Azan? Thank you. Okay, thank you so much for timing. Now come to the raster data. A grid or raster system store the data as a string of characters in which each character represent a location. In a raster data, each character, each pixel represent a location. The basic data unit is a cell or a pixel. Each cell pixel is assigned only one value. In raster data, each pixels have show one data that show the position of one data. An array of the pixels from the entity, points, lines, area, and surface. The shape and the size of the array determines the basic resolution of the image. Polygons can be formed, indicated area of the homogeneous characteristic. The polygon, when the polygon is formed in the raster data, when the data is homogeneous, mean the same data or the cluster data. This is the raster data that is represented. It show sand, grass, water, houses, and biome. So ID is 1, 2, 3, 4, and 5, and with the naming. Through this way, we have to show the raster data. Vector data. Data are associated with the point, lines, or the boundaries enclosing area. Vector data is in the form of point, lines, and boundary. Points are located by the coordinates. The raster data are located or denoted by the pixels, and the vector data are located by the coordinates. Lines are described by a series of connecting vectors. Line segments described by the coordinates of the starts of the vectors, its directions and magnitudes or length. Area or polygon are described by a series of vectors enclosing the data. Any number of the vector or attribute can be associated with a point, line, or polygon. Data are stored in two files: a file containing location information, a file containing information on the attribute. The data files are stored in two forms. One is about the information about the location, and the other one is information about the attributes, that is the latitudes and the longitude information. The third file contains the information needed to link positional data with their attributes, that from where we are collecting the data about the attribute of that position. We have to form the third one file. A vector system usually store the data as a coordinate in the form of a coordinate, that is latitude and longitude. For example, each uniform area is surrounded by a set of the straight line segments called the vector. In a vector-based systems, every point is recorded by a pair of the x and the y coordinates. If you are collecting the data through the GPS in a Excel sheet, you can get the data about the area, about the geography in the form of x coordinate and y coordinate. Straight line segments called the vectors are displayed to indicate the line based data, the road, river, and the wells. The x and y coordinates at the end of the each vector can be digitized and stored. Most spatial features can be displayed as a point, line, and polygon. We can represent most of the feature on the map in the vector data in the form of point, line, and polygon. This is the vector data through which we have to show about the sand, grass, water, and house, and building the same data that we have to show through the raster map. Vector and raster representation of the map of point map feature, how we represent the data in the form of point. Map feature in a GIS vector format, we have to show the data uh, in the form of x and y coordinates, and in a raster format we have to show the point data in the form of cell located or in the form of pixels. Is it clear? This is the vector and raster representation map feature, that is in the vector form we have to show the head to tail. You know what is vector? In a vector form we are collecting the data, we are find the map, we are find the models on a map in the rule of head to tail rule, means the head of one picks head of one area is attached with the tail of the another one. Through this way we have to find the full map of the area or full vector. So through the head to tail rules we have to form the vector map. This is called the raster format of the representation of the data, line data. The data is in the form of pixels attached with one another and form a line. This is the area representation of the raster and vector map. In a vector form, we have to represent the data with the help of the head to tail rules, that is in the form of vector. And in a raster format, that all of the data, the polygon data, is represented in the form of the pixels size. The pixels are collected and it form the area map. Comparison of raster and vector format, which now we are coming to compare the two types of the map, that which one is good, which one is better, which one is more informative, more easy to readable for us. So raster format are efficient when comparing information among arrays with the small cell size. If the size of the cell is small, so the raster format is efficient when comparing information among array. Vector format are efficient when comparing information whose geographical shapes and sizes are different. In a vector form, what is efficient? If the shape of the cell, if the shape of the geographicals are different from one another, like line map, road map, area map, point map. So that is easy, that is efficient, that we have to compare the information. Raster files are generally very large because each cell occupies a separate line of the data. Only one attribute can be assigned to each cell, and the cell size are relatively small. What is uh, if the data of the raster is safe in a file, it take a large of spaces. Why it take a large of spaces, very large? Because each cells occupy a separate line. In this the raster data, the file taking a lot of spaces. So there is a problems in your computer, in your data storage, because the raster data take a lot of space to store. Vector lines are much smaller because of the relatively small number of factors can precisely describe large area, and a many attribute can be ascribed to these area. As compared to the raster data, the file in which we have to store the vector data, it takes small spaces, small area, because of the attribution of the vector that are small as compared to the pixels of the cells. Raster representation are relatively coarse and impressive. Vector representation are shape can be very precise. It depends upon the shape of the road, it depend upon the shape of the well, or maybe just you have to show a simple small point. So the raster data are relatively coarse and impressive as compared to the vector data. Most GIS software can display both raster and vector data. Only a limited number of the programs can analyze both types of the data or make raster type analysis in a vector format. There are some limited software that they show the both of types of the data, raster and vector. Like Elvis is a software which is used for integrated land and water management system that show the two types of the data, the raster and vector format both. Now come to the attribute data. What is we have to study types, studying about the types of the data. The first one is the spatial data. The spatial data is divided into two types, that is different types. And now come to the another one type that is called the attribute data. The attribute data can be the numeric or alphanumeric data that is assigned to a point, line, or area spatial features. Alphanumeric means that we have to represent it by X, Y, and Z. Example attributes stand ID of the ID of the sample, compartment number, vegetation type, name of the forest in a block, types of the roads, and different types of the VSS code that we are using for our sample. So we are using that these themes or these names or these things in the attribute data. Nature of the spatial data, the geographic objective, spatial component, that is relative position between the object coordinate systems. Attribute component explains the spatial object's characteristic. Spatial relationships, relationship between the object, and the time component, that is temporal elements. So we have to show the natural nature of the spatial data, or what are the geographic objectives, what are their relationship with the attributes, with the data, and with the time. This is a spatial data that is about the month, that is no, not about the month, that is about the spatial and non-spatial data. In the spatial data we have to represent about the names and about the numeric and alphanumeric representations. And non-spatial data we have to address the name as all of these things in the form of a database. Spatial data criteria, like what are the criteria that the any spatial representation must have. That is, XY coordinates are very important to represent the spatial data. Shape, area size, parameters, distance, and the neighborhood which is attached to your area, a selected area or sample area. Attributes explain about the spatial data, that is revered non-spatial data, words or the numbers, qualitative methods and the quantitative methods. Through this way you have to cite the maximum and minimum limits, the number of populations, maximum population, minimum populations, and it is represented with different numbers, or maybe in different words you can represent your attributes on map. This is a GIS system, that data collection. You can collect your data from the different methods. You can collect your data from the maps and the plans, from paper file. You can collect your data through paper file. Different collect your information through paper files. You can take an interview of a person's. You can collect the data or information through a field survey. You collect your information through a remote sensing or aerial photography, or a different types of the photography. You can collect your information, and through a digital system you can collect your informations, and that information in the form of data. And after the collection of the data is stored into the computer here. And after the storage you can interpolate or manipulate the data in the form of different projections.
Now come to the data sources, from which sources we can collect that. Already we have to discuss in this map that we are collecting the data in different form. These are the sources of the data: existing data, that is digital map and plain paper files, and this data is low cost data. If we are collecting the data from the Google Map, if we are collecting the data from the papers, from the files which are already existed, and we are collecting the data by interviewing the person, so this data is called the low cost data. And for example, we are going to the field survey, so we are investing our money, our times, and our energy. So this data collection is called expensive. Remote sensing data collection is costly effective. Aerial photography is too much expensive, and the digital data also, you have to need any digital equipment for data analysis, for data collection. So all of these methods are the expensive and cost effective methods, and these three methods are called the low cost method, which is eco friendly methods. Acquisitions, the remote sensing, photogrammetries, and the field survey, these are called the high cost methods of the data sources or data collection. There is the query on the database and the graphics that you have to represent your database to the query graphic database, another one AB format may, or another format. You have to analyze your data, or you have to store your data. Available digital data. Original format sometimes needs to be changed into targeted formats. See example in handouts. Data may be built for different purposes. Quality of data not known. Spatial component from the maps and plans. What are the spatial component that we have to get from the maps and from the plans? Need to be changed into digital format, through scanning, digitizing, keyboard entry, coordinates, and the field survey. The quality of the data is known and controlled. This is the method through which we can scan our data, then put the data through keyboard into the computer, then digitizing the data, and the final product is in the form of the digital data map format or digitizing map format. Data acquisition, spatial components can be obtained by remote sensing, photogrammetry, survey attribute component can be obtained through remote sensing, photogrammetries, and interviews and the field visit. That is the methods of the data acquisitions, that data collection. Now, what are the attribute component? Retype from the maps, plans, or the hard copy files copied from the existing digital data. The attribute component you can get from the retyping, and from the maps you can collect the information. From the hard copy you can collect the information, or you can collect the information about your need, your samples from the digital data. That is called the attribute component. This is the method through which you can collect your data from the attribute component. Like you have a map, and that map contain a lot of information, a lot of layers of the forestry, agriculture, geography, and minings, and about the roads and the point, line, and polygon map. So you can collect your information, you can scan that information from the map, and you have to make your attributes in this form. And from that attributes you can make again another one map of your desired, your project map. Data entry involves 75% of the total implementation cost. Majority of the data entry methods require a lot of time. Data sharing enables lower data cost, that is existing data. Uh, in a GIS remote sensing processing, your all of the our input that is really needs, that is called the data entry. Data entry is a very tricky and really time consuming work or a thing that you are doing in the GIS and remote sensing analysis. So about your 75 percent of the total implementation or total cost that will be taken by the data entry. Majority of the data entry methods require a lot of time, and data sharing enables lower data cost, that is existing data. And which data is really lower cost data? That is already existing on the map in the form of graphs, or in the form of map, and in the form of graphic representation. You have the data, so that data is called the low cost data. Now, how to find the quality of the data? Misconception: the data from the GIS is of higher quality. GIS uses the latest technology. Quality of the GIS information depends on quality of the data. Garbage in, the garbage out. That is called the GIGO. Conventional methods usually decides for their own GIS. That's depend upon the data manipulations and the data entry persons, that which kind of the data he is needing. The quality of the GIS information depend on the quality of the data. If you have a data of your quality, if you have to calculate the attribute accurate, and if you have to find the GPS locations correctly, and you have to enter the data correctly into your computer, so your GIS information system result will be the quality result. This is called the quality result depend upon the cost. If you collected the data when you are going to the field, you are collect the data through the GPS, through the aerial photography, or through the field work, or through the digital method. You are collecting your data which are costly effective, but that data is called the quality data, because you are going to collect the real Earth's data. Spatial accuracy precisions indicate how closely several positions fall in relations to each other. How to find the accuracy? Accuracy is the measures of the closeness of the one or more positions to a position that is known and defined in terms of an absolute reference system. All of you know about the precisions and the accuracy. Accuracy means that the closeness of one and more position to the one another is known and defined in terms of the absolute references. That the data that you are showing, that are the points you are collecting, they are closely and accurate to one another, and closely uh, accurate, and in a precision indicate how closely several positions fall in a relation to each other. How to find the source error sources? Data acquisition, you can uh, make sure that there is no error in your data acquisitions. Devices and instrument error: first you have to find your device and instrument error, the data entry error, and the image interpretation error. The data conversion: instrument anachronisms and device instrument operators manuscript use, that you are using the manuscript, so take cares about that data conversion, that there is no error in your data conversions. That is really important point when you are going to digitize a map. Another one source, that is called the data storage store digital representation limit, disk storage limit used by the huge raster format. As I earlier told you, that is the raster format, that is the raster file. When you are going to save, it take a lot of space in your computer. So there is an error occur when you are going to store the huge raster format. Data processing, rounding off the errors, digital representations, error propagations, and propagation law: information derived by mathematical operations no more accurate than the original information, right? Uh, there is and data processing methods that you are rounding off all of the error. You have to remove the errors, you have to make the errors round off, then you represent the digital representation with a propagation law and mathematical operations. In a sometime we have to use the formula operations or mathematical operations, so no more accurate than the original information. Um that our today our presentations is divided into two parts, that is GIS information and GIS science. So first we have to discuss about GIS information and what is the difference between the GIS, Geographic Information System, and about the Geographic Information Sciences. Then the types of the GIS analysis, the types of method we are using for data collections, for presentations of the data in the form of maps, types of the maps that we are showing, feature of the map. Another one that is very important, that is the analysis of the geospatial that occur in the GIS information sciences. G Sir Shahab. Okay.